Hello friends. After seeing the overwhelming response of my previous videos, today I am going to discuss on the favorite question of interviewer for digital design engineer post. From my interview experience, after answering the tell me about yourself. This is the first question asked by the interviewer, as it gives good insights into the fundamental knowledge of candidate. Interviewer asks you to design the sequence detector for 1011 sequence and from my experience this sequence also going to be same as it is the best sequence to be asked. Sequence detector is sequential circuit that takes an input string of bits and generates an output 1 whenever specific pattern is detected. So as shown in the diagram, sequential circuit has combinational logic and memory to store the present state. We have clock, reset and inputs to sequential circuit which decides the output. As candidate, please cross-question the interviewer. Which type of sequence detector I have to make? Overlapping or non-overlapping? Melee or more? I personally feel that will have very good impact on the interviewer. Will show your grip on the basics. So, what is difference between non-overlapping and overlapping sequence detector? In overlapping sequence detector, we can consider the final bits of the sequence as start bit of new sequence. But in case of non-overlapping sequence detector, the state machine goes to reset state after sequence is detected. So, suppose we have input pattern as 1011011011. If you can see, 1011 pattern comes 3 times. 2 times pattern is separate as highlighted in yellow, but 1 time pattern in overlapping as highlighted in red. So, overlapping sequence detector will be give output 1 for all 3 but non-overlapping will be output 1 only for 2 which are highlighted in yellow. Now let's focus on what is melee and more machine. The basic difference between the melee and more machine is that for melee machine present state and inputs generates the output or output is dependent on both present state and current inputs. And in case of more machine, present state only generates the output or output is dependent on present state only. Both have their own advantage and disadvantages. Features of melee machine are as follows. Number of states is less, so in some cases flop count to implement will be less. So, for area critical designs, this is one of the important point to be considered. Hardware requirement, combinational, for circuit implementation is more. This becomes important when there is scarcity of combinational logic elements as in case of field programmable array. I will discuss in detail about FPGA in some video. For now, just remember that FPGA has huge number of flip-flops as compared to the combination logic elements. Faster response to inputs, this is important point for timing critical applications. Output is asynchronous. Input transitions changes output. Feature of more machine are as follows. Number of states is more, so in some cases flop count to implement will be more. Hardware requirement, combinational, for circuit implementation is less. Slower response to inputs, output changes on next clock edge. Output is synchronous. After having all these information, we are ready to make the state diagram for all 4 combinations. First melee machine, overlapping sequence. Second melee machine, non-overlapping sequence. Third more machine, overlapping sequence. Fourth more machine, non-overlapping sequence. First step is to determine that how many states will be there for state diagram. So number of states depends on only whether state diagram is Mealy based or Moore based. For n-bit sequence, Mealy machine will have n states. Moore machine will have n plus 1 states. So for 1011 sequence we will have 4 states for Mealy machine and 5 states for Moore machine. For Mealy we will have as 0 state or reset state and as 1 state in which we have got the 1 and. Then S2 in which we have got 1 0 and final state S3 in which 1 0 1 we have got. As discussed earlier that Mealy machine output depends on both present state and input. So that's why we don't need the state in which we will have information that 1011 is detected. That we can infer from the state S2 in which 101 we have got and if we have input as 1. Similarly, Moore has 5 states, 1 more than Mealy. S0 state or reset state and S1 state in which we have got the 1 and. Then S2 in which we have got 1 0 and final state S3 in which 1 0 1 we have got. But in case of Moore, we have a state for 1 0 1 1. As discussed earlier, Moore the output is dependent on present state only, so we need this state to generate the high output. So let's start making the state diagram. I will start making with the Mealy. In Mealy we have two cases, overlapping and non-overlapping. One thing to remember is that in case of Mealy we show the transitions with input and output both, as output is dependent on the present state and input. So, let's first discuss the Mealy non-overlapping sequence. At start system we will be at reset state S0. I follow simple procedure. I make first the pattern to be detected transitions only. At S0 reset state if one input comes then present state will so to state S1 with output 0. At S1 state if 0 input comes that present state will so to state S2 with output 0. At S2 state if 1 input comes that present state will so to state S3 with output 0. At S3 state if 1 input comes that present state will so to state S0 with output 1 as it is a non-overlapping sequence detector. Then I start making other transitions. If at S0 reset state 0 input comes then present state will remain at S0 only. If at S1 reset state 1 input comes then present state will remain at S1 only. If at S2 reset state 0 input comes then present state will go to S0 state. If at S3 reset state 0 input comes then present state will go to S2 only. Almost same steps we have to follow for the overlapping detector also. But at the end state we have to change as it is overlapping sequence detector. If one come at S3 state then state will not change to S0 reset state. L state will change to S1. That is only the difference between two state diagrams which is highlighted in red. Let's look into the Moore machine state diagram. As we have already discussed, Moore machine has one extra state. Same state is highlighted in yellow in the diagram. And transition shows only input not output as the output is not dependent on the present inputs. Output is dependent on the present state so its output value is shown below the state name in the state diagram. I will end this video here. We'll cover the next question asked by interviewer after this. That is, write the Verilog for the state diagram you have drawn in the next video. Thanks for watching this video. Please like and subscribe my channel. Please don't forget to press the bell icon to get the notification of the new videos I will upload.